Hello everyone, I hope you guys doing well. Today I want to review about electronic analog instrument. Before that I want to introduce myself. My name is Lintang Banyu Bhineka and RP 023 11 84 000 0093. And then we're going to introduction and background. In instrumentation standard, we're using 4 to 20 mA signal. Any process parameters such as temperature, flow, density, pressure are measured by a sensor and is converted to electrical signal in the form of voltage and then sent to the transmitter with standard current signal, which means 4 to 20 mA. As you can see as figure out, the transmitter output signal 4 to 20 mA. We have a problem and aim. The first one is what is the 4 to 20 mA current loop. The second one, relation 4 to 20 mA signal with instrument variable, and the third one is application. We have aim to know the all of these. As you can see, we can analogy current loop signal with a water flow analogy in industry. Voltage we can analogy as a pressure, loads we can analogy as flow resistance, and then current as a flow. As you can see in the video, the current travel in the wire, and then when in the water flow, the flow travel in the tank. And then we're going to component of 4 to 20 mA current loop. The first one, we have a sensor to measure a process variable such as temperature, such as the density, pressure, or etc. And then we're going to transmitter, convert sensor measurement into a current signal 4 to 20 mA, and then we're going to power source to supply a voltage because the system needs a voltage to do their work. And then we have loop, the wire connecting the sensor to the device receiving the 4 to 20 mA signal, and then back to the transmitter. And then we finally get receiver at some place in the loop. There will be a device which can receive and interrupt the current signal, and then we can monitoring the system with receiver, as you can see as figure out. And then we're going to relation 4 to 20 mA signal with instrument variable. Most in the world instrumentation industry, a minimum of 4 to 20 mA current loop signal are used. One represents the process variable, as you can see as PV, process variable, and then other signal represent the output signal from controller, or commonly we know as MV or manipulated variable. And then we have a measuring device, IR sensor, and then we have controller, and then we have final control device as actuator or control valve, and then we're going to process. For linear instrument, we have equation which y means m times x plus b. Y is output, x mean input, m is gradient, and then b is bias. As you can see, value equals span per unit plus LRV, and then value equals URV minus LRV per unit plus LRV, which means we can get span in URV minus LRV. And then we're going to signal of process parameters. As we can see in figure out, 4 milliampere it means 0%, and then 20 milliampere it means 100%. If instrument signal show 0 milliampere, it means there is no power supply in the instrument signal cable. It means the cable must be lost or current must be lost, and the cable maybe have a problem. 4 to 20 milliampere current loop overview. The 4 to 20 milliampere current loop is the prevailing process control signal in many industries. It is an ideal method of transferring process information because current does not change as it travels from transmitter to receiver. This is almost much simpler and cost effective than others. We have an application of 4 to 20 milliampere current loop. In this video we have a controller, and then we have a transducer and control valve. The controller sends signal to final control element, which in the case control valve. This controller, there are current source dependent current source providing a current output of 4 to 20 milliampere DC. For example, when the mode in the controller is changed to manual and the output is set 50%, the DC current coming out of the controller is 12 milliampere. If everything goes good, the current in the loop will still be 12 milliampere even though there is a slight change. Okay, next is application of 40-20 milliampere with Orifice plate in differential transmitter. When the flow passes through the Orifice plate, as you can see as figure out, it creates a pressure difference where P1 and P2 Orifice plate makes the difference pressure and decrease from P1 to P2, and then the transmitter will detect the differential pressure here and then convert to flow rate, and then going to convert to 4 to 20 milliampere signal. So this is a system for measuring flow rate. We have a flow rate and current output. When the flow rate is 30 gallon per minute, it's mean 4 milliampere, and then when the current output is 12 milliampere, it means 65 gallon per minute, and then when the current output is 20 milliampere, it means 100 gallon per minute. And then we can going to get flow rate with differential pressure square pressure means flow rate. And then when the flow rate get, we can go to convert to current output to travel to monitor or indicator maybe. Okay, this is a reference that I made in this video. First one is Gilang Pratomo with the title Instrumentasi Elektronik Digital dan Analog, in book in Instrumentasi Industri Surabaya, and then published by academica.edu, page 37 into 56, and then Precision Digital video with title Back to Basic, the Fundamental of 4 to 20 milliampere current loops, with date 2040. And then that's all for this video. I hope I'm sorry for my mistake, and thank you for watching. Goodbye.